In the previous lesson, we looked at problems that had a mass of a substance. So for something like water or sand, it would be very easy to change the mass of the object. We could have 25 grams of water just as easily as we could have 35 grams of water. There are times when an object has a fixed mass. In those cases, we use a slightly different reference value to do calculations. In that case, we use something called the heat capacity, which is different than the specific heat capacity. So heat capacity is the energy needed to raise the temperature of an object of a substance by 1 degree Celsius. So this has units of joules per degree Celsius or calories per degree Celsius. Notice that the units of grams are missing. And this is used for objects that are a fixed mass, such as a container, or a lab device, or in this case, a wooden spoon. So the wooden spoon is not going to change mass between uses. It's going to have the same heat capacity, even if the water that it's stirring is going to change in mass from time to time. When we have heat capacity instead of specific heat capacity, we have a slightly different equation that we use to see the relationship between the heat and the change in temperature. We still have Q, which is the heat. This still has units of energy, which can include joules, kilojoules, calories with a little c, or calories with a big C, i.e. kilocalories. C, with no subscript of the S, is known as the heat capacity, has units of joules per degree Celsius or calories per degree Celsius, so some unit of energy over the temperature. And then we have our delta T, which is the change in temperature, which is the same as saying temperature final minus temperature initial. And this can be in either degrees Celsius or Kelvin. Remember, we learned that because of the way we convert between Celsius and Kelvin, a delta T, or change in temperature in degrees Celsius, is equal to the change in temperature in Kelvin. Let's look at an example. 100 joules of energy is applied to a wooden spoon at an initial temperature of 22 degrees Celsius. If the spoon has a heat capacity of 79.5 joules per degree Celsius, what is the final temperature? Even if you confuse the names of specific heat and heat capacity, you can always look at the units. Heat capacity will not have the mass in the units, while the specific heat capacity will. We look at the problem and we see we have 100 joules, we have 22 degrees Celsius as our initial temperature, and we have our heat capacity. We can plug those values into our equation. So we have 100 joules equal to 79.5 joules per degree Celsius times the final temperature minus the initial temperature, which is 22 degrees Celsius. I divide both sides by 79.5 and get 1.26 equals TF minus 22. We then add 22 to both sides and get 23.26 as our final temperature, and rounding for sig figs, we get 23 degrees Celsius is our final temperature. Like specific heat capacity, every object will have its own heat capacity. However, because it's specific to an object, these are not reference values. One wooden spoon could have a heat capacity of 79.5, another wooden spoon could have a heat capacity of 82.3. So these are not listed as reference values. Let's do a comparison of specific heat capacity and heat capacity. So specific heat capacity is the energy needed to raise the temperature of 1 gram of a substance by 1 degree Celsius. Heat capacity is the energy needed to raise the temperature of an object of a substance by 1 degree Celsius. This is an object with a fixed mass. They have slightly different units. In specific heat capacity, we include units of grams. We do not in heat capacity. And we use slightly different equations. For specific heat capacity, we have Q equals M times CS times delta T. In heat capacity, we have Q equals C delta T. A common question from students is how to figure out which one to use. Well, the first thing to look at is, am I given a mass of a substance? If you're given a mass, then you're going to have to use the Q equals MCS delta T. If you're given a specific heat capacity with joules over gram degree Celsius, so the gram is included, you're going to be using specific heat capacity. If you're not given a mass or the heat capacity is given and it clearly does not show a unit of grams, then you will use the equation Q equals C delta T. The important thing to do is remember each equation and then look at your units. Notice for specific heat capacity, mass is included in the equation, and so CS must have grams in there in order to cancel out.